YB. Very good.
Okay.
So dy will be dx. So I know that this portion will be y to 1/2. This portion will be dy, correct? Now I have to make up this.
Right.
In order to make that up, I have to solve for x.
Right.
So x equals y minus 2. Therefore, x squared will be y squared minus 4y plus 4.
Oh, we have to break it out. Okay, that's what I didn't do.
Yeah, you have to do that.
Okay.
Because now the new integral.
Because you have to, and then you have to distribute the y to the 1/2.
Right.
Okay.
Right.
Okay.
So then I will have to multiply. So it's y squared minus 4y plus y times y to positive 1/2 times dy. Now can you finish it up from here?
Oh,
Do we have an answer?
yes, ma'am. Yeah, 2/7, times y to the 7/2 minus 8/5 times y to the 5/2 plus 4/3 times y to the 3/2 plus c. I guess we just substitute.
And yes, then we have to substitute, replace y by x plus 2 or 2 plus x. Any questions?
Five more. And that long thing at the bottom is the final answer.
Yes. Can I verify? I have doubts about this. This is an indefinite integral. Can I verify?
Yes, ma'am. I've taken the derivative of both sides.
Of both sides, exactly. Let's verify. Just for this one. So my claim is this. Right? Right? This is my claim. And I have doubts about my work for whatever reason. So I will differentiate this side, and I will differentiate this side. When I differentiate the left-hand side, what do I get?
X squared root of 2.
Right? Because differentiation and integration are inverses of each other, inverse operations. This will kill this. Now on the other side, bring down 7/2. 2/7 times 7/2 is 1 times x plus 2 to 7/2 minus 1, which is 5/2. Minus 8/5 times 5/2 multiplied by x plus 2 to 5/2 minus 1, which is 3/2, plus 4/3 times 3/2 times x plus 2 to 1/2, and plus the constant prime. Okay? I have not finished, so I should even just put the square, question mark there, because I have to show you I haven't finished. So this side is, take the integers out, so it's x plus 2 squared times the square root of x plus 2. So this is 4/2 plus 1/2. This will be 4/2, and this will be 1/2.
Okay.
Then minus 4, and this will be x plus 2, and the square root of x plus 2. Agreed so far? Plus 2, and this is the square root of x plus 2. So far so good?
Yes.
I will factor out the greatest common factor of these three, which is,
Square root of x plus 4.
now this is x squared plus 4x plus 4. This is minus 4x minus 8, and this is plus 2.
No, someone did math right. Uh-oh.
Which means I have to go back
Uh-oh.
and check my stuff here. Because all these terms should have gone,
Yeah,
right? Because
Yeah.
I have to have x squared times this.
right.
So all this
Should go
should be
on.
just x squared. So I have to go back and redo my stuff. That's how we check. 1 point off on the final exam. Got it, Chris? Okay, so this is the integral of 2 plus 1/2 is
5/2.
indeed. So it's y to 5/2 minus 4, y to 3/2, and plus 4, y to 1/2 dy. So this is indeed,
So y to the 7/2.
that's true, and over 7/2 minus 4, y to 5/2 and 5/2 and plus 4, y to 3/2 and 3/2 plus a constant c. So 2/7 times x plus 2 to 7/2 minus, indeed, 8/5 x plus 2 to 5/2 and plus 8/3. That's the only mistake you had. It's 8/3 here. X plus 2 to 3/2 plus a constant c. So this has to be 8 right here. 8/3. Okay, so now if I go back, so this is 8/3. So I have 4 here.
So 2.
So this is 8/3. So I have, so this is 4 instead of 2. Ah! Voila. So yes, indeed, we have no doubt now that this is the correct antiderivative or the function. This is how we check. Any questions? Anything else? Any other topic that you would say, I need to see one more of that? You will have an approximation with the midpoint rule again, because you have. I want you to make sure. I want to make sure that you remember that you can really calculate an approximation for anything. It's not going to be exact. It's not going to be perfect, but for any integral, even if you can determine the antiderivative, maybe there isn't one, then you can still approximate that.
So I have a question about the area of the function.
Right,
Right.
under the graph.
So
Right.
I guess if the xy plane goes on infinity in every direction, why, once you cross the x-axis, does that go? I mean, I know it's negative x, but I mean, it's still area.
Yes, because you can have a negative area. You can
Right.
have, very good question, actually.
So if we're computing the area